Me now?
Yes, I can.
Okay. If you can hear me now, I think we are good to go. We are good to go.
Record.
Okay, so today's topic is electrolysis. Electrolysis. Okay. Uh, can you hear me?
Yes,
Okay. Okay. So quickly, let's take a look at what is electrolysis. First of all, let's take this one out. Okay, electrolysis is first of all, before we talk about electrolysis, let's remember what is electric current. Electric current is the flow of electrons round a circuit. You remember that? Electric current is the flow of is the flow of is the flow of charge round a circuit. When you say electric current is the flow of charge round a circuit, is that okay? So when we say electrolysis, electrolysis is when an electric current is passed through a multi-ionic compound, like lead 2 bromide. Okay, like lead 2 bromide. You take a multi-ionic compound, you pass electric current through it. When you pass electric current through a multi-ionic, multi-ionic compound, they're good conductors. They are conductors of electricity. You know, right? If a compound is in is a multi-ionic state, then it's a conductor. It can conduct electricity, right? So when you pass electricity through it, or when you pass electric current through it, it will dissociate the ion into the positive and negative ion, right? It will break the compound into positive and negative ion, right? Are you with me? Are you with me?
yes,
Okay, so if you break the compound into negative, like lead 2 bromide will be broken into lead ion, Pb, Pb 2 plus on top, and bromine ion, Br minus on top. Okay, so it will broken into this ion, lead ion and bromine ion. Lead ion is the positive ion, and the bromine ion is the negative ion. So it will decompose them into ions. Okay, the compound will decompose into ions, right? So whenever you pass electric current through a multi-ionic compound and it is able to decompose them into ion or break them down, and then we say electrolysis has taken place. Are you with me?
yes,
Now the process also occur for aqueous solutions of ionic compound. Any aqueous solution, you know the meaning of aqueous solution, right? Aqueous solution of ionic compound. So the process also occur for aqueous solutions of ionic compound. Whenever we take a solution, first of all, you know the meaning of a solution. Okay, something that dissociates in liquid. So aqueous solution of ionic compound, when you pass electric current through it, it will dissociate it, break it down into its component ions. To break the compound down or the solution down into its component ion. Now, covalent compounds cannot conduct electricity. You know this, right? Why? Because covalent compounds are compounds that are between two nonmetals, right? It's a bond between two nonmetals. Okay? Nonmetals are not good conductors of electricity. Ionic compound is a bond between metals and non-metals. Okay? Wherein the metals, they donate some electrons from their outermost shell. They give to the non-metal. The metals, they give the ions from their outermost shell. They give to the non-metal. They donate. They give whatever they have. For example, like sodium chloride. Sodium is Na, right? Sodium chloride has 1 plus on top. So it gives the electronic configuration is because the atomic number is 10, the electronic configuration is 2, 8, 1, or you say 2 plus 8 plus 1. That's the electronic configuration, meaning the first shell of the electron that revolve around the nucleus has 2 electrons. The second shell has maximum of 8 electrons. and the third shell has only one electron. The third shell has only one electron. So that one electron, sodium will donate it. Sodium will donate it and give it to. Sodium will donate it and give it to chlorine, because chlorine its atomic number is 17. So the electronic configuration is 2,8,7. So when you give the one from sodium to chlorine, chlorine will now be 2,8,8, which or 2 plus 8 plus 8. So chlorine will not obey octet rule. To obey octet rule, it will have all the maximum number of electrons in their atmosphere, which will be 8. They will be stable. And sodium will be stable as well, because it has given its one little pair of electrons that is making it unstable. It has given it out to chlorine. So covalent compounds themselves, they cannot conduct electricity, hence they do not undergo the electrolysis process. So whenever we're looking for our electrolyte, what we call electrolyte, a substance that can conduct electricity, we do not include covalent compound, because they themselves cannot conduct electricity, and they do not dissociate to produce these ions. You remember, they don't give, you know, when they don't donate, the composition, the bonding, they don't donate, they only share. You bring like carbon and oxygen. Carbon bring 4 electrons in the atmosphere. Oxygen bring 2 oxygen atoms. One bring 2, the other one bring 2, and then they share. Then they will each have 8. So they don't donate. When you don't donate or you don't receive, then you will not have ions. You will not have ions. When you are sharing, you are just bonding covalently. When you're sharing, you're bonding together covalently. But when you share, when you give, you become an ion. When you lose an electron, you become an ion. It's always those compounds that give and receive that can undergo electrolysis process, or that can be used as electrolyte. That can be used, those compounds that can donate ions or receive ions, that can be used as electrolytes. Are you with me?
Yes.
Okay, let's move on. Now we say ionic compounds in the solid state can also conduct electricity. We need it either in multi-state or in aqueous state, aqueous solution state. If ionic compound is in the solid state, it cannot conduct electricity. Do you understand what we mean? If you have a compound in a lump, in a solid, in a lump form, in a solid form, it cannot conduct electricity. Okay? Why? Why is it that if it's in a solid state, it cannot conduct electricity? Because at that point, it does not have a free ions. It does not have free ion when it's in a solid state. It needs to be in a multi-state. Okay, need to be in a multi-ionic state, or it needs to be in a aqueous solution state in order for it to conduct electricity. In order for it to have the ions to be able to move freely. In order for the ions to be able to move freely. Okay, so that's it. Now, electrical conductivity of ionic compound. Let's take a look at some ionic compound and test or look at their electrical conductivity. The first one, take a look at this solid. You can see we have, this is like a solid form sodium chloride. You have plus, minus, plus, minus, plus, minus, like that. Okay, then you have multi-solution. In multi-solution, you see there are little space between the plus, minus. You can see there are little gaps here and there between the plus, minus, where the electrons will be able to slide through or move through a little bit. Okay, so in a multi-state, then the electrons are able to move. Okay, now particles in ionic compounds are either in a fixed position in the solid state, but can move around when they are in multi or in a solution form. Okay, so when they are in a solid state, they are in a fixed position. When they are in a solid state, they are in a fixed position. When they are in a multi-form or in a solution form, the particles or the electrons or the ions, whatever you want to call them, they're able to move freely. Is that okay? So that's why, because the electrons are able to move freely or the particles are able to move freely, that's why they can conduct when they are in multi-state or in solution state. So remember, compounds in multi, ionic compound in multi-state or in solution state can conduct electricity. But ionic compound in solid state cannot conduct electricity. That's the point we're trying to make. Is that okay? Now let's go to the terms that are used with electronic cells. Let's take a look at the basic terms that are used with electronic cells. The first one is electrode. When we carry out electrolysis, the first one is the electrode. There's like these two pillars. You know, when you look at this diagram, if you take a look at this diagram, you see a positive pillar, like a positive pillar, and a negative pillar. These are called the electrode. These are called the electrode. They are called the anode and the cathode. They are called the anode and the cathode. They are called the anode and the cathode. Okay, so electrode is just a rod of metals. A rod of metal. The metal could be graphite. The metal could be copper. It depends. We can use any metal to act as our electrode. Is that okay? So electrodes are just rods of metals like graphite, through which electric current flows through or flows into and out of an electrolyte. Through which the electric current, remember the electric current is the battery you are using here. Like this place, the top part, this top part where you see the power supply in this diagram. So the power supply is usually here, in this case, usually the battery, for example. So this battery, you know, current flows through the battery and pass through the electrodes, passes through the electrode into the electrolyte. Electrolyte is the compound that you dissolve in solution in this basin. Okay, electrolyte is this color, green color that you dissolve, this solution looking green or looking blue, whatever color you can perceive or you can conceive here. So this is called the electrolyte. This is called the electrolyte. This is called the electrolyte. Okay, are you with me?
Yes.
Okay, so this is called the electrolyte, and these two rods, they are called the electrodes. And the current flows through this electrode to the electrolyte. When the current gets here, it will dissociate the ionic in solution or in multi state. This ionic compound is no longer in solid form. Remember that. It's in solution form or is in multi form. So it will dissociate them, it will dissolve them. To dissolve them into component ion, into positive and negative ion. It will separate them into, remember ionic compounds are usually positive and negative ions. The positive from the metals, the negative from the non-metals. So it will separate them into two. That's the first thing you're seeing here. Okay, we've talked about electrode. We know what is that. Now we've also talked about electrolyte. We say the electrolyte is the ionic compound in a multi or dissolved solution that conduct the electricity. Okay, the electrolyte is this solution that is in this basin. Should we call this one a basin or whatever you want us to call this one? This trough or a basin where we dissolve this ionic compound. The ionic compound must be in a solution or in a multi form in order for it to conduct electricity. So current flows through to this to this electrolyte and dissolve it into ions. Now let's move on. We've already talked about what is electrolyte. Electrolyte is the compound that we dissolve, the electricity we break down into its ions. Now let's go to anode. Anode is the positive electrode of the electrolysis cell or of the electrolytic cell. The positive electrode is called the anode. You know we have two electrodes. The positive electrode is called the anode, while the negative electrode is called what? The cathode. The negative electrode is called the cathode. Now let's talk about the cations. Cations are the positively charged ions which are attached to the cathode. You know, cathode is a negative electrode. It will be since cathode is a negative electrode, by laws of nature, or laws of you can say laws of electromagnet, laws of electricity, by natural laws of electricity, it is the positive ion in the electrolyte. In this case, let's say lead. Assuming we are doing lead bromide. Lead has 2+. Okay, Pb, then 2+ on top as a on top of it. That lead bromide, that lead will be the one that will be attracted to the negative electrode. You remember, positive is always attracted to negative. laws of life, laws of nature, laws of electricity, laws of magnetism, is all like this, right? The positive is always attracted to negative. So the positive ions from the electrolyte, you know, electrolyte is dissolved nitrate ions, positive and negative ion. Now this positive ion is attracted or migrates to the negative electrode, which is called the cathode, while the opposite happens in the other case. The same opposite, the negative ions like bromine, for example, I'm just giving you for instance, the negative ions like bromine will migrate to the positive electrode. So negative ion will go to positive electrode and positive ions will migrate to negative electrode. That's what happens. Is that okay? So cations are when we say cations, they are the positive charge ions. Is that okay? Now anions, quickly, let's take a look at the anions. Okay, before we talk about anions, look at the ions. Negative, the negative ions are called the anions, right? So look at the negative ions are called the anions, right? These anions, they migrate to the positive electrode. They migrate to the positive. I already mentioned that. So we say the negative ions, the negative anions lose electrons at the positive electrode. This negative one, they will lose electron at the positive electrode or the positive anode. When the negative ion migrate here, they will lose electrons. They will lose what? Electrons. They will lose what? Electrons. When the negative ions come here, they will lose their electrons when they migrate to the positive anode. Then when the positive cations come to the anode, they will gain electrons. They will gain electron. Which electron do they gain? The electron that was lost here at the electron that was lost at the anode. The electron that was lost at the anode will be gained here by the positive cations. So here they will gain electron. When they gain electron here, they will become what? They will become lead. It will become lead. This one will lose electron to become a bromine gas. This one will lose electron here to become. So at the anode, at the positive anode, the negative ion will lose electron to become like bromine. Negative ion will lose electron to become a bromine gas. While at the cathode, which the positive cation will gain electron to become lead. Is that okay? So that's what is happening in electrolysis. That's the whole story. What is happening in electrolysis? The basic principle, fundamental principle. Metals and hydrogen form positive charge. In electrolysis, if you use metals, they form positive charge, and also hydrogen form a positive charge. Hydrogen also form positive charge. Okay, anytime we have hydrogen, it will form a positive charge. Okay, these positive charge are the ones that migrate to the negative electrode, which is called the cathode. Are you with me? This positive charge of metals and hydrogen are the ones that normally migrate to because they have positive charge, they are called cations. They are the ones that migrate to the cathode. They are the ones that migrate to the cathode. While the anions, which are negative negative ion, they migrate to the anode, which is the positive electrode. So the anion will lose electron at the anode, while the cations will gain electron at the cathode. Is that okay? So we say the metals and hydrogen, they form positively charged ions, and so either a metal or hydrogen gas is formed at the cathode. So it's either we get a metallic gas from metals or from hydrogen. Now non-metals form negatively charged ion, and so non-metals except hydrogen are formed at the anode. Non-metals are formed at the anode except hydrogen. Hydrogen always is with the metals at the cathode. Is that okay? Now let's take a look at electrolysis in terms of looking at charge transfer. looking at charge transfer. Somehow, I think I have explained this concept somehow. Now, what happens is that during the electrolysis, current needs to flow right around the circuit. In order for the current to flow, charge must be transferred around the circuit, right? Right? Current is defined as the rate of flow of charge. We already know this from basic physics or from basic science. Current is the rate of flow of charge, right? Now, so to get the charge that will flow, we need a power supply like a battery. I think I've already explained these basics. We need a power supply that will provide, a power supply provides the cathode, right, with a supply of electrons. Provide the cathode with a supply of electrons, right? So we say a power supply provides the cathode with a supply of electrons, causing it to become negatively charged. Now let's take a look at the diagram to illustrate that. This is a battery, right? This is your power supply. You see the electron will flow from this place, negative side of the battery to this. Charge will flow from the positive side to this way. So this flow of electron into this place will make this one to become the cathode. You know, when you take two rods, if you take two metals, two rods, like graphite or any metallic substance, you cannot tell which one is positive, which one is negative. So the question, first and foremost, you should ask me is how do we know which one is positive and which one is negative? We don't know at the beginning. But the moment you connect them with a battery, electron will flow to one side and positive charge will flow to the other side. The one that has electron flown into it is called the cathode. It becomes a negatively charged electrode. The electrode that has electron flowing into it becomes the what? The negatively charged electrode. Now it will become cathode. Then the one that has charge flowing into it, the positive ion flowing into it from the battery, will become the anode. That's the first step. Are you with me?
Yes.
Now, we said the positive ion, that's the cation in the electrolytic move. They move towards the cathode. The positive ion, I've already explained this one. The positive ones, you know, where electricity flow into this one, to dissociate them into positive and negative, the solution will break down to positive ion and negative ion. Then the positive ion will now flow to this negative side. They will be attracted. You see them from this diagram. The positive cation, they are attracted to the cathode. Cathode is the negative electrode. Why is it negative? Because electron is flowing from the battery to it. That's why it's negative. Then the positive ion, that because of electricity that has flown into this solution or this multi substance or multi ionic compound, then it will dissociate it will break down into positive ion and negative ion. The positive ion will be attracted to the negative electrode, while the negative ion from this place, they will migrate here. They will migrate and be attached here. That's the first point of call. So we say the positive ion, which are the cation, they are called cations, in the electrolyte, move towards the cathode, and then where they gain electron. So when they move here, they will gain what? Electron. Why would they gain electron? Because electron is all here. Electron has already flown here, right? Electron has already what? Flown into this electrode, and it has made it a cathode. So they will gain the electron. They will gain it to themselves, right? So they will gain the electrons, right? Then the negative ions that migrated to this electrode, the positive electrode, okay, the negative ions, which are called the anions, that migrated to this electrode, they will what? That migrated to this electrode, what will they do? In the electrolytic from this electrolytic move, they move towards the anode, right? And then they will lose electron. They will lose their electron.
Yes.
Yeah, they will lose their electron to the positive. You know, this one is positive now. This anode is positive because it has charge. Charge is flowing into it from the battery, so it's positive. So negative will always lose to the positive, right? So they will lose this one will lose their electron to the positive anode, right? They will lose their electron. Now the electron move from anode back towards the power supply. The electron that they lost here, the electron that they lost, you know, these anions, they will lose their electron, right? And go into this anode. And this electron will flow back to the battery. And then to this side again. It will be a continuous process. Then the electron will continue again to enter here. When the electron enter here, it will be able to attract more positive ion. Okay, because the positive ion will gain electron here. While the negative ion that is attracted here, they will lose their electron. Okay, because charge are flowing in here. So when this negative ion comes here, they will lose their electron. The electron will flow back to the battery, and the process will continue. The process will continue. Are you with me?
Yes.
Are you with me?
Yes.
So the electron move from the anode back towards the power supply. So in a complete circuit, electrons are the charge carrier in the external circuit. We say the electrons are the charge carrier. They are carrying the charge. They are the charge carriers in the external circuit. Ions are the charge carrier in the electrolyte. Ions carry the charge here. Electron carry the charge here. Ions carry the charge in the electrolyte, while electron carry the charge in the external circuit, which is this the one that is connected to the battery. Okay. So here we gave a vivid example. We call this one sodium. This electrolyte is sodium chloride. So it breaks down into sodium ion. That's the one you see here on your left. Into sodium ion, Na plus ions. And then on the other side, the opposite side, you have what we call the chlorine ion. To break down chlorine raised to power minus, so chlorine ion. So the chlorine ion will migrate to the anode, and then they will lose their electron. The electron will flow back to the battery. And then when the sodium ion migrates to the cathode, they will gain electrons. They will gain electrons. Okay?
Yes.
So let's move on. I think you got that diagram, right? I think that's the first part. I think we should now move to the next one. You want us to take some tests? Okay, let's go to the next one. Now we go to 4.1.2, electrolysis of multi-compounds. We take some specific compounds. Now we carry out their electrolysis. Okay? So we say a binary ionic compound is one consisting of just two elements joined together by ionic bonding. Okay, we've seen like sodium chloride. Okay. We have here, we want to look at this electrolysis, and we take here an example. We usually lead bromide now for this case. We take a multi-lead bromide, okay, multi-lead lead 2 bromide, multi-lead 2 bromide, and put it in this base, and then we put 2 electrode. This could be carbon electrode, okay. We take 2 electrodes. The one that where charge flows into is the anode. The one where electron flows into is the cathode. So when they flow into this, it will dissociate the multi-lead into ions. So lead 2 lead plus 2 ion and bromine minus ion. 2 bromine minus ion. Okay, so then like we said, the bromine ion will migrate to the positive the lead ion, which is positive, will migrate to the negative electrode, and the bromine ion, which is negative ion, will migrate to the positive electrode. So you can see from here, each bromine ion loses one electron at the positive anode. Each bromine, each one will lose one electron at the positive anode, at the anode here. Okay, are you with me? Each bromine ion, this one, each bromine ion, this one, will lose one electron, okay, at the positive anode. So 2 bromine ions are needed to form a bromine molecule, right? In order for us to form bromine molecule is Br2. In order to form bromine molecule, we need 2 bromine ions. So minimum of 2 bromine ions. So we need 2 bromine ions to lose their electron to this place, and the electron will flow back to the battery and to come back through to the other side. Okay. Then let's take a look at the other side, the positive side, the negative electrode, cathode. At the cathode, lead ion gains 2 electrons from the negative electrode. The lead ion gain 2 electrons at the negative cathode, forming lead solid. So look at it. It will gain electron. It will gain. Lead ion gains 2 electrons because it has 2 plus. Lead has 2 plus. Okay, lead ion is 2 Pb 2 plus. So it has to gain 2 electrons in order to become lead solid. To gain 2 electrons, these are the electrons from here. Look at the electron. To gain at least 2 electrons to become a lead metal. Okay, to become a lead. Is that okay? Lead solid. While on the opposite side, bromine. Each bromine atom will lose 1 electron. Each one will lose 1 electron, and we need 2 to lose 2 in order to become a bromine molecule. Okay, so that's what is happening. That's what is happening in this electrolysis. So at the end of the day, what will you have in your anode and what will you have in your cathode? A bromine gas will be formed at the anode. Am I right? A bromine gas will be bubbly off here because it will lose 2. Each bromine ion will lose 1 electron. We need 2 of them to lose 2 electrons in order to become a bromine molecule, and a bromine gas will be formed at the anode. So you see a bromine gas bubbly off because bromine is a gas. Bromine is a gas. You see bromine gas bubbly. You see a bromine gas bubbly off at the anode. Are you with me? Then what happens at the cathode? What happens at the cathode? Lead solid will be formed, right? At the cathode. Is that okay? So this is the electrolysis of multi-lead bromide. This is how we carry out electrolysis of multi-lead bromide. These are the method. This is just describing all I have explained. That you should set is actually describing this diagram. How you set up this diagram, and then you get your result. Okay. Now here is a question. Let's see. Identify the product form at the anode and the cathode during the electrolysis of multi-potassium chloride. Multi-potassium chloride. What we've done is lead bromide. For multi-potassium chloride, what will be formed at the anode and what will be formed at the cathode? Who wants to try? Huh? Who wants to try? You know, potassium chloride is the electrolyte, right? That will be when electricity enters into the electrolyte, we dissociate into potassium ion and chlorine ion. So what will happen? Can someone just try and tell me what will be formed at the product that will be formed? Just now I just described lead bromide for you. I say lead bromide. Bromine gas will be bubbly off at the anode, while lead metal will be formed here. Lead as a metal will be formed at the cathode. So in the case of potassium chloride, what will be formed at the anode and what will be formed at the cathode? Can someone try? Yes. No, don't waste time. Okay, do it. You get back to me. Okay. Now let's move ahead. Can we move ahead? Okay. Next topic. Okay. All this is an advert. Okay. So don't take them serious. Now let's take a look at electrolysis of aqueous sodium chloride and dilute sulfuric acid. Let's take a look at the electrolysis of aqueous sodium chloride and dilute sulfuric acid. At the end of the day, we will send the notes. Okay, so you copy the notes. Is that okay? So the electrolysis of aqueous sodium chloride and dilute sulfuric acid. Here, the electrolyte is, the first electrolyte is sodium chloride, right? Table salt, aqueous sodium chloride. So this is called brine. Why is it brine? Because we're going to dissolve salt in water. So there are two things now. There is salt, there is water. So water ion will dissociate. Water will dissociate to hydrogen ion and OH ion. OH ion and hydrogen ions. That's water will dissociate to that. Then the sodium will dissociate it to sodium plus ion and chlorine minus ion. Are you with me? So in the electrolysis of brine, in the electrolyte, we have 4 ions, not 2. You know, usually we used to have 2. One is positive, the other one is negative. Now we have 2 positive and 2 different positive and 2 different negative. The 2 positive would be hydrogen plus ion is positive and sodium plus ion is positive. That's what we have in the electrolyte. Then the 2 negative will be chlorine ion negative from sodium chloride, chlorine minus ion negative, and we also have OH minus ion negative. Okay, so that brine is a concentrated solution of aqueous sodium chloride. The word brine, it means a concentrated solution of aqueous sodium chloride. Now, it can be electrolyzed using inert electrode. What type of electrode? We can use an inert one. We can use platinum electrode or carbon electrode. So it can be electrolyzed using inert electrode made from platinum or carbon. When we say carbon now, usually with graphite, we can easily talk about graphite. Are you with me? We can easily talk about graphite. We can carry out the electrolysis using graphite. Is that okay? Are you with me?
Yes.
Okay. So when electrolyzed, it will produce bubbles of gases at both the electrodes as chlorine and hydrogen. You know, chlorine is a gas, hydrogen is a gas. So these 2 bubbles of gases will be produced. Now, in this case, why is it hydrogen that goes to the cathode, not sodium? The way it works, one of the rules is that, you know, like I said, if you open the electrolyte, there are 2 positive and there are 2 negative. If you come to this diagram, the 2 positive ions are what? Sodium ion, you see Na plus, and hydrogen plus ions. Why is that? Like we said earlier, you dissolve the sodium chloride, a concentrated solution of sodium chloride in water. So two compounds are coming together. The water ion will dissociate into hydrogen ion and hydroxide ion, right? OH minus. Hydrogen plus and OH minus. The water will dissociate into that. While the sodium chloride will dissociate into what we call the sodium chloride will dissociate or dissolve into two, which is sodium and chlorine. Now, during migration, you know, once electrolyte is dissolved into positive and negative ions, they will now migrate to their opposite side. So the positive ion will all migrate to the negative electrode, which is called the cathode, while all the negative ions will migrate to the positive electrode, which is called the anode. Now, when they migrate here, which one will not take precedence? Which one will suffice? Which one will eventually produce the product? Only one product, despite two ions migrated here, which is chlorine ion and OH ion. Are you with me?
Yes.
Despite that happens, OH, you can see the OH here, OH minus. Okay? Despite you see OH minus ion, and chlorine, only one of them will take precedence. Now, there is a rule for it. Okay? There is a rule for it that states which one goes. Now, for electrolyte, if it's a concentrated solution of potassium bromide, if it's a concentrated solution of potassium bromide, it is hydrogen that will go to the cathode, because you know it will produce hydrogen and potassium in the electrode. Hydrogen will go. Hydrogen is the junior brother. Potassium is the senior brother. The senior brother will send the junior brother to go to represent him. Just similarly, the same thing is going to happen here. Look at the cathode. We have the sodium ion. We have the hydrogen ion. Sodium is the senior brother according to reactivity series. According to chemical reactivity series. In reactivity series, sodium is higher than hydrogen in the reactivity series. So in my old world, I call it the senior brother, the big brother. So sodium will say, okay, junior brother hydrogen, please can you represent me in this Olympic? So hydrogen will represent sodium. So hydrogen will be the one that will suffice at the cathode eventually as the product. So hydrogen gas will be seen bubbling off, okay, here. Hydrogen gas will be produced, in other words, that's so to say. Hydrogen gas will be produced, in other words, okay. Then this other side, chlorine will be produced instead of OH ions. Okay, there's no gas called OH ion. Chlorine will be produced in this regard. Chlorine will be produced, okay, because it just needs one electron. Okay, so chlorine will be produced quickly. So we say, first of all, in the electrolyte, sodium chloride solution, which is called brine. They always bring this in the exam, so pay attention. Sodium chloride solution is always called brine. It turns into sodium and hydroxide solution. It will turn into sodium and hydroxide solution. It will turn into sodium and hydroxide solution. Is that okay? Then the sodium, like we already said, the sodium will migrate to the cathode, while the hydroxide, OH, ion will migrate to the anode. But that's not the only ions that are produced. We also said there is chlorine ion, which will also migrate to the anode, and there is a hydrogen ion, which will also migrate to the cathode. So when that happens, at the cathode, hydrogen will display, be sent by sodium, say, okay, you replace me, and hydrogen gas will be produced here, and chlorine gas will be produced at the anode. Is that okay? So we say the product you see at the positive electrode, the positive electrode, which is the anode, what you see there, you see chlorine ions, all right? This chlorine ion, they are discharged at the anode. They are discharged, they are displaced. By who? They are discharged, okay? They are discharged, okay? Then they lose electron and chlorine gas is formed. they are the one that will lose their electron to this positive anode, and then chlorine gas will be formed. Is that okay? Then at the other side, you have what we call sodium ion and OH ions. They will remain behind, right? And then they will form sodium hydroxide solution. These two will remain behind here in the electrolyte, in this basin, in this trough. They will now fall back. They will fall down back. They will fall back to this place. Because the sodium did not go, the sodium ion did not go, and is not produced at the cathode. Since hydrogen is the one he sent, he will come back, he will return home. And then the OH ion from the anode that did not go will also come back. So sodium and OH will now they will form sodium hydroxide. So at the end of the electrolysis of bi, we produce about three things. We produce chlorine gas at the anode. We've produced hydrogen gas at the cathode. And then inside this place, the electrolyte, we still have what is left called the sodium hydroxide. Sodium hydroxide is also produced. Are you with me? Now the product are the negative electrode, which is called the cathode. Hydrogen ions are discharged at the cathode, as they are less reactive than hydrogen and than sodium. They are less, like I said, they are the junior brother. They are less reactive than sodium. So they are like the junior brother. So they go. While sodium falls back. The hydrogen ions gain electron to form hydrogen gas. They will gain electron, they will become hydrogen gas. So there are two gases produced in the electrolysis of brine, which is sodium chloride, concentrated solution of sodium chloride. That's brine. So there are three products, but there are two products produced at the electrode. The hydrogen gas produced at the cathode, and the chlorine gas produced at the anode, and then sodium hydroxide produced in the basin, in the electrolyte. Okay, so these are the three products that are made at the end of this one. Now let's take a look at the dilute sulfuric acid. Okay, I will stop after this particular one. We will stop. Okay, after this particular, let's quickly take a look at dilute sulfuric acid. I think after this one, this section will finish. The next section will be 4.1.3, right? We're in 4.1.2, right? Okay. Okay, we are doing 4.1.3 now. Next session will be 4.1.4. Okay, now let's take a look at the electrolysis of sulfuric acid. Okay, sulfuric dilute one. You know, we have dilute sulfuric acid and we have concentrated sulfuric acid. We have dilute sulfuric acid and we have concentrated sulfuric acid. Now let's take a look at the dilute sulfuric acid. Dilute sulfuric acid can be electrolyzed using inert electrode made from either platinum. When we say inert electrode, it could be platinum electrode or carbon or graphite. Okay, it can be used as the electrodes. You can use any of this for the electrolysis of dilute sulfuric acid. Now, at the end of the day, bubbles of gas are seen at both electrodes, just like the one we've seen just now. The one we've seen just now of electrolysis of brine, that's a concentrated solution of sodium chloride. Concentrated solution of sodium chloride, the one we've seen just now. We saw that the hydrogen gas was produced at the cathode, while the chlorine gas was produced at the anode. So two gas bubbled off just now. So likewise, this case, gases are seen at both electrodes. But let's see what happens. How are they? The product at the anode, let's take a look at the negative at the cathode. Let's take a look at the negative electrode, which is called the cathode. In the cathode, remember, sulfuric acid is H2SO4, right? H2SO4. So H is a hydrogen. Hydrogen ion will migrate to the cathode, right? Hydrogen ion will migrate to the cathode, while OH ion, hydroxide ion will migrate to the anode. We're going to talk about each of them. Now let's take a look at what happens at the cathode, the negative electrode. Hydrogen ions are attracted to the cathode. they gain electrons from there. You know, when you get to cathode, you gain electron. Cathode has electron. Electron is coming from the battery. So they will gain electron at the cathode. When you gain electron, they will become hydrogen gas. When ion gains electron, they become hydrogen gas at the cathode. Now let's take a look at what happens at the anode. The positive electrode is called the anode. Now, you know the electrolyte is hydrogen, H2SO4, sulfuric acid, H2SO4. That's the electrolyte that will dissociate to produce hydrogen ion and SO4 ion or OH ion. But the OH ion will migrate to the anode, the positive electrode. Now these OH ions are attracted to the anode. They will lose electron. Here, you know, at the anode, you lose electron. You don't gain electron. You lose the electron you have, because there's no electron to gain. All you have is a positive, positive charge. So you have to lose your electron so that the electron can carry the charge back to the battery. So here they will lose their electron and become oxygen gas. OH ion can only form oxygen gas and water. Oxygen and water is what is produced. We're going to see the equations. Okay, what we call the half equation at the anode and at the cathode. Okay, now let's take a look at determining what gas is produced. If the gas produced at the anode releases a glowing split, then when a glowing split went deep into a sample of the gas, then the gas is oxygen. You know, the test for the gas, you put the gas here in a tube, put the gas in a tube and put a small matches, light up a matches, bring it close. If it continue, it support the combustion more. If the burning increases from little light, little burning to more of burning, then the gas that is here is oxygen gas. That's the test for oxygen gas. You know, oxygen support combustion. So when you bring the gas that is produced at the anode, which is oxygen gas, you know, oxygen is produced, water is also there. So to know whether the gas is oxygen, you test it by putting in a test tube and bring a glowing split. Bring any glowing split, anything that can burn, like matches. And when it supports it, it continues to burn more, then you know that the gas that is produced is a oxygen gas. Now, if the gas produced at the anode bleaches a damp litmus paper, then it's a chlorine gas. That's the test for chlorine gas. If you bring a litmus paper, if you see that it does not support a glowing split, and then you bring a damp litmus paper, another test criteria you can do is to bring a damp litmus paper. If you see that it turns a blue litmus paper red, you brought a blue litmus paper, the color is now changing red, then you know that this is what? A chlorine gas. This is a chlorine gas, right? From blue to red to white, you can see the eventuality from blue to red and eventually turning to white. So then you know exactly that this gas is a chlorine gas. Now, the gas, we are just telling you how to test for the gas to know what gas are produced at every point in time. If the gas make a pop sound, let's say you bring a glowing split to it and it make a pump sound, boom. If you make boom, then this gas is hydrogen. Hydrogen make pump sound when you bring it close to any of the gas. Anything that is burning, a little split, bring it close to hydrogen gas, it will make a pump sound. When this pump sound is made, then you know the gas is hydrogen. So this is the end of this section. This is the end of this session. Thank you for joining this section. Thank you.